Inside a live compressor hall at a Gulf Coast LNG terminal, human inspectors have to navigate a maze of 180-degree Fahrenheit steam lines, toxic gas monitors, and ambient noise pushing past 95 decibels. During a routine walkthrough, a two-person crew spots a critical anomaly. A compressor bearing is overheating. The inspector writes, "Bearing looks hot," on a paper clipboard, and the team moves on to the next checkpoint. At the end of the shift, that handwritten note is transcribed into a spreadsheet. Because the maintenance planner only reviews this specific log every few weeks, the data sits dormant while the equipment continues to run. The financial impact of that administrative delay is catastrophic. 3 weeks later, that $100 bearing seizes, destroying a $1.2 million compressor and triggering a 14-day unplanned shutdown that cost the facility $8 million in lost production. The human workers correctly identified the threat. The failure was the time gap between collecting the data and actually executing the repair. Automating this data collection is difficult because industrial environments are hostile to traditional robots. A machine on wheels or tracks is effectively trapped when it encounters graded flooring, navigating steep stairs, or a chaotic pipe rack. Quadruped robots solve the terrain problem through dynamic balancing. These machines autonomously navigate unstructured environments, correcting their posture in real time as they step over the exact same obstacles a human inspector would face. By utilizing biological leg structures, these platforms remove the physical barriers that previously restricted automated data collection in heavy industry. Once the mobility problem is solved, the quadruped acts as a synthetic inspector. A single autonomous patrol consolidates thermography, acoustic monitoring, visual checks, and gas detection into one continuous route. AI-powered visual cameras allow the robot to audit the site for safety compliance, instantly flagging missing guardrails, spotting unsecured excavations, or absent fire extinguishers. This thermal imaging screen shows how specialized payloads make mechanical stress visible. The quadruped measures the internal temperature of working machinery from a distance, without ever making physical contact. Instead of relying on an inspector's subjective judgment, the robot evaluates this heat data against a calibrated baseline threshold for that specific asset. Combining constant visual safety audits with absolute thermal grading eliminates subjective human error from the inspection process. The robot also listens for failures. Using ultrasonic microphones, it filters out the ambient plant noise to isolate the specific high-frequency pitch of a microscopic gas leak or a grinding internal gear. In complex petrochemical facilities like this, even a single spark can be deadly. Many areas are designated as ATEX Zone 1, meaning they are permanent explosive hazard zones. To safely operate here, specialized spark-free quadrupeds use integrated atmospheric sensors to smell the air, detecting volatile chemical leaks down to the parts per million level. The quadruped processes this thermal, visual, and acoustic data locally using Edge AI. Decisions happen on the machine's own internal chips in real time. With local processing, the quadruped functions as an active decision-making engine, evaluating industrial threats the moment it encounters them. Returning to the initial scenario, the quadruped walks through the compressor hall, and its sensors detect that same overheating bearing. The machine pushes the anomaly data directly to the facility's computerized maintenance management system via API, bypassing human data entry entirely. The software auto-generates a prioritized repair ticket containing the thermal image, the exact GPS coordinates, the severity grade, and the required repair action. This automated software loop eliminates the fatal time delay between spotting an industrial hazard and ordering its repair. Deploying these systems has an immediate human impact. Facilities can reduce dangerous confined space entries for human workers by up to 80%. Industrial strategy is shifting from reacting to catastrophic emergency failures to predicting them autonomously using high-frequency sensor data. By linking raw environmental data directly to maintenance software, these machines ensure every observed threat translates into immediate action.